Okay, thank you for coming back today at our channel, The Physics Mindset. We are still on the process, we are still on the line of transmission. We're gonna leave transmission after knowing everything in transmission. I don't want to leave anything behind for you. I need you to understand everything so that you can know the transmission system clearly. Now, today we are going to dig into the transmission line parameter. Transmission line parameter. Listen this word. It is not perimeter. It is parameter. Parameter, whereby parameter we are meaning the characteristic of the performance of a system. Okay? Anything, the characteristic of the performance of the system. And perimeter, check this is the difference. You know, some people may call it transmission line perimeter. No, transmission line parameter. Like parameter, not perimeter. There are two words, parameter and perimeter. Parameter is the characteristics or the quality of the performance of a system or a performance of a system. Now, the perimeter is the total distance. Remember in geometry we used to learn this, like this is the total distance around a shape. Let's say if we have a triangle and here it is 10, where this is length is 10 meters, width is 5 meters. What is the total distance? This is when you're learning perimeter. Now this is a triangle. This is 10 and length is 10, width is 5. Meaning if the total distance around the shape, it is the perimeter. The characteristic of a system, it is a parameter. Or the quality of a system, parameter. Now the perimeter of this, here you just put 10, here you put 10. What is the total distance? No, here 5. Because this is width. The same length, the same length, the same length, the same length, the same width, the same width. This is 20, this is 20, this is 5, 30 meters. This is parameter when you're studying in geometry. But parameter is something different. And this is what we are going to look at. The parameter. The transmission line parameter. This is our line. This is our pylon. Okay? Another pylon. Rough estimate. Don't laugh. This is our conductor. Conductor. We said the first one on top is earth. Earth wire is small on top. Then phase 1, live 1, live 2, live 3. Now, these are the conductors. The first one is not carrying any current, is earth, which we called ground. You remember the last video talking about this earth wire only. Now we are going to talk about these conductors, which you see, they are not only transferring electricity from one place to another. These conductors have characteristics, have electrical characteristics inside them, which you want to look at. Not only we say that conductors are carrying electricity, but we need to look at technically, engineering, to see what is these conductors, what are the line parameters, what are their parameters, what are the parameters of these conductors. We need to check technically. If you stand there and you see when you're designing how these pylons are going to be, consider the electrical characteristics. One of the parameters, we are going to call them parameters. These are the characteristics which affect the voltage. These wires have some characteristics, electrical characteristics, which affect the voltage. The voltage is passing through these cables, right? But there is something affecting it. Electrical characteristics which affect the voltage. It affects also the current. those characteristics inside these conductors, transmission line parameters. They affect also the power. These are different things in electrical, as you know, if you have been following the channel. If you're new on the channel, please subscribe, like, and comment any part which you want to learn most. And we shall type in the comment section, then I can come up, tell you something which you want to know about any topic. Okay? Now, these things will be affected by some of the parameter, the transmission line parameters, or the conductor parameters, or the conductor characteristics, the quality of performance of these conductors. Now we are going to look at 3 of them, though they can be 4, but mainly we shall look at 3 of them, which are main, which you need to understand as a student in electrical, as an electrician, or as an engineer in the field. We are going to look at 3 of them. The 3 of the transmission line parameters. What are these parameters? Number one is resistance. Resistance. This is number 1 parameter in a transmission line. These are the transmission lines. But one of the parameter is resistance. Parameter, it affects something which affects the performance of a system. That is a parameter. It is, I told you, it is different from perimeter. Perimeter is total length of the shape of anything. As we have seen here, total length of this triangle, if 10 side, 10, 5, 5, which is 30 meters, this is perimeter. But parameter is different. The characteristics of these conductors, electrical conductors. Now, we have a conductor. We don't just see a conductor transmitting electrical power, transmitting voltage, transmitting current. There are some effects in these conductors. Effects in these conductors. These effects, these are the parameters we are talking about. One of the parameters we are seeing, we have the resistance. All these parameters, I know you know them, but you need to know them basically inside it, what it does. What if we talk about resistance, what resistance means? Now, resistance, this is number 1 parameter. We're going to look at them personally. Like resistance, we talk about each and you understand it very well. Okay? Number 2, we have inductance in these transmission lines. The transmission lines, there is some inductance, that effect of inductance, which affect voltage, it affects current, and it affects power. Inductance. Inductance. This is the second parameter, the inductance. First was resistance, second is inductance. The third one is capacitance. Capacitance. Resistance, inductance, capacitance. All this affects the voltage in the conductor, affects the current in the conductor, affects the power, causing power loss. Yet when we are transmitting this electricity, what we are fighting for, not to lose our power. We want our power to travel and it reaches the final destination when it is the way we have manufactured it or the way we have generated it. Because we talk about generation in electrical, then after generation we need to transmit this power. I told you, like for example, you are staying in a certain country, wherever you are, USA, France, Uganda, Nigeria, everywhere, South Africa, Zimbabwe, Namibia, Italy, wherever you are living in a certain area of the country, let's say an eastern part of the country. Now in that country, in that side of the country where you're living, they generated power because there is a waterfall. On the waterfall, they generated hydroelectricity power. After generating hydroelectricity power, they had to transmit this power from eastern side of the country where you're staying to western side of the country, or northern side of the country, or southern side of the country. what do? They transmit this power, generated power, from one place to another by use of this transmission tower, as we studied them in the last videos. If you missed these videos, please go back and watch them so that you understand. Don't be late. You're not late. Go back and read and watch the video. Understand what is in the video about the transmission tower, about these conductors. Now, after transmitting this power from eastern side, it is going in western side of the country, whichever side, north or south. Okay? Now, if you want to transmit the power, let's say our power is, let's say 220 kilowatt. Now, if you want to transmit 220 kilowatt, what is a measurement for power? K is 1,000, meaning this is a 220,000 watts. You want to transmit this from eastern side of the country to the western side of the country. What do? There are some things you need to do so that all this power is carried and taken to the western side of the country. But in the event of this electricity moving through these conductors carried by the pylons or the tower, there is some electrical characteristics inside these conductors. Remember, I told you these conductors are atoms made from atom. An atom has either electron, proton, and a neutron, whereby electron is the one which moves around the orbit, and proton, they are in the center, in the nucleus of an atom. In the nucleus, there is also a neutron. Neutron is, as you hear it, neutral. It's either charged by negative charges or positive charges. Only proton is charged by a positive charge. Electron is, which moves around the orbit, is charged by an electron, a negative charge. Whereby these electrons, when they are moving, they find difficulties in the moving because of the material of the conductors. Now, these materials of the conductors have resistance in it. This is the number one parameter we are seeing. This resistance affects the flow of voltage, current, and our power. What is the use of the voltage? You remember, I told you the simplest definition for the voltage, which you can use to simplify everything. It is the pressure or the force. It is an electrical force which pushes electrons to flow in the conductor. Now, these are the conductors, live 1, live 2, live 3, three-phase. If these conductors, if there is no resistance, why would we need the voltage? The voltage is something which push. If there is no resistance, let's say, if the water, let's try to talk about the water pole. If you want to raise water from one place to another on the hill, you will need a pressure, water pressure, which will push that water. Now, in electricity, if we want to take current or power from one place, current from one place, current is the movement of electrons. Now, if you want these electrons to move, you need something which pushes it so that it moves from one place to another. Now, that thing which moves is the voltage. That's why we need voltage. It means there is some resistance. One of the parameters we are having, resistance in it. I'm trying to explain resistance. Okay? Trying to explain this one. Resistance inside, it will resist the flow of current. That is the definition of resistance. Resistance, you define it as the opposition of the flow of current, opposing current from flowing. For it, it is there to block current from moving. Now, pressure, the voltage will push this current even though there is resistance. Now check when you have aggregates or these small stones. If you put them there on the rod and you pour water, water will flow through these stones, the aggregates, but until reach the other side. But it has faced some difficulties in moving. Okay, now that difficulties, that is the resistance. Now in electrical also, every property which has the conductance of electricity has the property of resistance, one of the parameters. Okay, now this voltage will push current to flow in the conductor. But power, when current faces a lot of resistance in the conductor, our power will be lost. We shall lose a lot of power. How do we lose a lot of, the way we lose a lot of power is by these conductors will start feeling red heat, will change current into heat energy, meaning it will change electrical energy into heat energy. The moment this conductor, and we are not using this conductor by them, we are just transmitting it. We want it to reach the other side, but the resistance inside the conductor is making current to fidget to pass through. For the best example is the cooking coil. You see that cooking coil which is like this. Okay, this side is connected to live, and the ending part, this ending part is connected to neutral. That is the connection of the coil. When the current, when you plug your cooker in the socket, okay, you plug it in the socket. This cooker, the live part, current will pass through the live, voltage will be pushing current through the live. Okay, it starts slowly. Observe this coil one day. It will start slowly from point A, from point here, going slowly, heating up, turning into red hot. This heating up is the same principle how current fidget to pass through the transmission lines. One of the parameters, the resistance, is inside there. It will not allow current to pass, and once it doesn't allow, current will heat up, and once current heat up, our coil here turns into red hot. That's when you can cook your food. Okay, that's the principle. And neutral will act as a return. Now this, your coil to turn into red hot, it is not just something. If you are technical, you will know this is the principle, how it turns into red hot, because of high resistance, which is measured in ohms. High resistance will make this coil to turn red hot. Current fidgeting to pass through the conductor. That time of fidgeting, it will turn into heat. The more heat, it makes this coil a red heat because of high resistance, which is applied also in the conductors when we are transmitting our electricity from one place to another. Okay, now how do engineers try to solve the power loss? When we are doing this calculation, like the best formula when you're calculating resistance in this cable, how this cable and how these conductors, electrical conductors, face that resistance, we use the formula of resistance, which is equals to rho L over A. A, whereby rho L divided by A. This resistance, rho is the resistivity the resistivity of these conductors. If you're a student, they will give you a resistivity number for certain conductors. Either they're using aluminum or gold, I don't know. Resistivity number will be given. Now, L stands for the length of the conductor, the length of these wires in meters. Divide by A. A will stand for the cross-sectional area. Cross-sectional area, I told you, is like, this is the cable, this is the wire, okay? But on the first part of it, this is the wire. On the last part of the wire, it has a cross-sectional area. This is the cross-sectional area. This is a wire which comes like this, one wire, like this one, okay? If it is live and neutral. This is live and neutral. Now, they have their end. The end point. If you look at the end point, you will see that is the cross-sectional area of the end point. Now, this cross-sectional area is where we measure our cables. That this is a 2.5 millimeter, 1.5 millimeter, 4 millimeters, 16 millimeters. Because of the cross-sectional area, if the cross-sectional area is small, it depends. Now, its measurement comes. This is where we get these terms. 2.5, 1.5, 16 millimeter, 3 millimeter, 4 millimeter, 10 millimeter, because of the cross-sectional area measured in millimeters. Okay? Now, this power, when there is resistance, power will be lost because in terms of heat, our cable will heat up. That heat, which we don't use, is called a loss of power. Which formula we use? The only formula when you're calculating loss of power, we use power, loss of power, power loss. When you're calculating a power loss, you use the formula of current squared resistance times resistance. Because current is fighting with the resistance. And you will have power loss in terms of heat. In terms of heat. That's why our power loss, these coils consume a lot of power. That's why these coils, you may find it is a small coil having 3000 watts, 3000 power. Whereby our bulb, we use, it may be 1 watt. How many 1 is in 3000? This is the coil. When the coil is heating up, it consumes a lot of current. A lot of power is going to be taken. That's why our coils are measured in high wattage. High wattage. Watts. 1000 watts, 1500 watts. And most of the people, when they are buying coils, I know the knowledge comes and you run on checking how many watts are of that coil it uses. Though some other people don't know how to calculate the money taken, the units which will be consumed by this coil because of a high power consumed, high power loss. This is the high power loss. Now, high power loss, we use the formula of current squared times resistance. They will be giving you, or they will indicate for you. If you're doing exams, you will have this formula always. Now, if you want to save your power saving, okay, we shall increase the voltage. Engineers came up that to fight this resistance, which makes our power loss, current squared times resistance, they decided to increase the voltage. Increase the voltage, increase this voltage to high voltages. Now, the transmission voltage, they generated, let's say, they generated, I don't have space, they generated 11,000. This is 11k volts. This is the generation voltage. Now, 11k, they stepped it up by a step-up transformer to 4,000 k volts. This is 4,000 400,000 volts, 400k volts, from 11k volts to 400k volts. The moment they step up voltage, current goes down significantly. And once the current goes down, our power will not be lost. Power will, this is the current, like in the coil. I'm giving you an example in a coil. When current is passing through the coil, after plugging into your main switch, current will flow in. Now, when you reduce on the voltage, the power, the pressure, when you increase the voltage, which pushes current to flow, current will come down. That's why we use a formula of power, not when power is not lost, and the power which is generated will be the same power which you reach at the point after transmitting. Once you increase the voltage, current will come down, and our power will stay the same. There will be no high power loss, and that's why we shall use a power formula of which formula? Current times voltage. Here we are talking about current times voltage. When you're talking about power loss, because of the resistance, we use current square times resistance, and our power will flow the same. If it is 220 kilowatts, we shall, at the end of, after transmitting, still we shall have our 220 kilowatts, the same power, if you increase the voltage. That's why on the transmission, they never wanted to transmit 11k. They decided to step up the voltage to 400,000 volts, so that our power remains constant, doesn't change. Okay, that is the parameter, the transmission line parameter, the resistance, which affects the current. Now we are going to talk about also the inductance. How does this inductance affect the transmission electricity or transmission power? We need to understand things clearly. Don't forget, try to write something down. Summarize something down. Summarize the video. You will understand with the time. These things you will be used in your field, in your technical time, when you need to apply the knowledge. Okay? Now, let us talk about the inductance, which is the number 2 parameter in the line transmission parameters. Number 2, inductance. Let us try to look at it. Let me rub off this, and now you have learned what resistance, what the parameter, one of the parameter is resistance. And I know now you have some knowledge about the resistance, how resistance affect the conductor. There's affect the electricity which is passing through these conductors on the pylons or on the transmission towers. Now, let's talk about parameter number 2, which is the inductance. Inductance. You remember when you are generating electricity, there is something we learned about the electromagnetic inductance, whereby inductance comes with magnet. Let me simplify for you this. When current, this is our cable. Okay? Now, current, this is current. Okay? When current, always, we are talking about AC, alternative current. When an AC is passing through a conductor, this is a conductor or a cable, it produces, when electricity is passing through a cable or any wire, just it creates what we call magnetic fields around it. when current is passing, or when voltage, or when SC is passing through a conductor, it creates magnetic fields around it. These are the magnetic fields. Magnetic fields around it. Magnetic fields around it. When this is the cable, around when voltage is passing through the cable, around it, magnetic fields will be there. And this magnetic field, since SC, it goes on off, it alternates, as the name, alternative current. It creates these magnetic fields, and these magnetic fields, the power which is pushing this current to create these magnetic fields, this magnetic field will create a changing magnetic field, will create what we call an induced current. Induced current, when it is changed by this magnetic field, this magnetic field can create electricity. That's why I told you, when you want to create electricity, if you get a magnetic field, if you get a magnet, two magnets, and you put a cable in the middle, and you start playing with your magnet like this, there is this magnet have magnetic fields around them. When the magnetic fields play around the cable like this, this is your cable. You get your magnet, a south pole, north pole, south pole. Then you get another magnet, south pole, north pole. You start turning them like this with a high speed. Okay, just leave the cable on one position, then turn the magnets. Turn these magnets. Remember, they have fields. Okay, if you turn them, and this is what we call magnetic induction. And induction will penetrate into the wire, and this wire, you will have an electromagnetic induction inside the wire. Now we shall have a voltage here. Trust me, you shall have a voltage. That is how electricity is generated in a generator. You know why you pull a generator like this? Just to turn these magnets. And these magnets, the moment they are turning, they send their magnetic fields, and a changing magnetic field creates an induction, and this induction creates a voltage. And this voltage, this process is called inductance. This process is called the inductance, which we are studying today. One of the parameters in transmission lines, the inductance. That is the process of inductance. And these conductors which are passing on the pylons, this inductance depends, it has some of the factors which it depends on, okay, to determine on the transmission lines. One of the factors we have is spacing, the conductor spacing, live 1 and live 2. How far are they from each other? Because we said one cable, one conductor is carrying some magnetic fields around it when voltage is passing through it. One of the factors which this inductance has is the spacing, conductor spacing. Conductor spacing. The spacing of this conductor, they have space. Because if it is high voltage of 400,000 volts, kilovolts, meaning also the voltage, the magnetic fields will be high, with meaning you don't need to put these conductors close to each other, because a changing magnetic field will cause an effect on another cable. Now, if these cables are two, they are two near. This one is having magnetic fields, and also this one is having magnetic fields. Do you know that one of the cable will push their magnetic fields because it is carrying high voltage, 4,000 volts. One of the magnetic fields of one conductor will jump, will be induced, what we call inductance, will be induced into this cable. And once it induced, it will affect the flow of current. Okay? It will oppose a change in current. Current is passing through this second cable also. These are the pylon. Magnetic fields jumping into, inducing into this cable will affect the flow of current. Meaning, it's one of the parameters in a transmission line. Another, this is now they need to space them. You need to space, have it. If you look at them, they have enough space, avoiding this, the effect of inductance, whereby induction in one cable carrying electricity will have some magnetic fields, which magnetic fields, when they are near, these magnetic fields will jump and enter into another cable, because now they collide with this one. Colliding will create resistance opposing the flow of current in this another cable conductor, meaning they have enough space. They need to be having enough space. And one of another factor which affect this inductance, the conductor spacing, there is also the conductor radius. Conductor radius. Radius, I mean the radius, the cross-sectional area of the conductor. As I told you, this is the conductor. A conductor, if this is a wire, at its end, if this is a wire, at its end is the cross-sectional area or the radius. It is a bit circle like this. Now, this is the radius, the cross-sectional. Now, it depends on the radius, the conductor radius. Is it big enough? If it is big enough, meaning it will create also very large magnetic fields. It will have less resistance, because we said if the cable is big, it will allow electrons to move, meaning electrons will not see much resistance when they are moving. Like you, when you're moving through a small corridor, when you are many, you'll have resistance, you'll push each other, and still you'll reach at the door, at the output. But you'll have resistance pushing to each other. Whereby, if they give you a very big room of passing, just know everyone will be passing freely. It comes also in the conductor. If it is small, resistance will be high. Current will be opposed by this resistance. Now, if the cable, the cross-sectional area is big, it means also the cable is big, because the cross-sectional area is the one which determines the cable. That's why when we are talking about 2 meters, 2 millimeters, give me a cable of 2 millimeters, give me a cable of 1 millimeter, give me a cable of 4 millimeter, 16 millimeter, 10 millimeters. We are talking about the radius of the cable or the cross-sectional area of the cable. Okay, and it has this is the second factor of the inductance, which determines the inductance on these transmission lines. Now, what else? We can have also the behaviors of the magnetic fields of another conductor, which we have talked about. The magnetic fields. The magnetic fields of this another conductor, whereby if these fields are induced in another conductor, they affect the flow of current. Okay, now When you're calculating this, if you're a student and you are asked to calculate for inductance, okay? Inductance, there is inductive reactance. We shall say inductive reactance. You will use a formula of XL, which will be, this L represents inductance. L represents inductance. XL, which is 2 pi FL. F will stand for frequency. Frequency. System frequency. Frequency of the system. Okay? Hope we are together. The system of the, but this is the formula you will be using. XL 2 pi frequency times inductance. When you are calculating the inductance in these cables, in these conductors. Okay? And this is another parameter. We saw about the resistance and we have seen about the inductance. The inductance mainly talks about the magnetic fields. When current is moving through a cable, it creates magnetic fields. And these magnetic fields, if they are changing, they oppose the flow of current in a conductor. And it is an effect to these transmission lines, which engineers are seeing. For someone else who doesn't know this knowledge, will just see that and know that those cables there, those transmission lines are carrying voltage. But you can go much in details with the knowledge, technical knowledge, engineering knowledge, to know about these terms, the engineering terms, the resistance. There is resistance taking place in these cables. Any cable overhead, there is resistance. There is inductance inside there. Magnetic fields are over there. There is what we call capacitance. Let me rub off this, then we talk about the capacitance, which is our last parameter in the transmission lines. I told you there are 4. But we shall explain up to, I will give you the fourth one is not mainly, is the resistance, inductance, capacitance and conductivity. Because this is conductivity. Yes. Resistance has the other formula which we saw. Resistance, let me see, rho L over A. Rho is the resistivity, of the conductor. But there is also what they call conductivity of the conductor materials. Okay, let me rub off and we talk about the capacitance. One of the parameters, the third one, then we can close up the video. I want you to understand the things, the transmission. Now, for the capacitance, I know now we have knowledge on resistance, one of the 3 parameters, the resistance, inductance, and capacitance. Now let us look at this capacitance. What is this capacitance? On the 3 parameters which affect the characteristics of the transmission lines. Okay? Now, this capacitance, as you know, it deals with the charging current. This capacitance is, let's say, capacitance of this electrophases, phase 1, phase 2, phase 3. It will depend, their capacitance will depend on their spacing. One of the factors which determine the capacitance of the conductors on the transmission line is their spacing. Their spacing will bring a lot of effect on the capacitance of a conductor. If it is spaced well, it will mean, remember, with this inductance, induced current from the magnetic fields. Now, when you space well these cables, these conductors, their capacitance will be fine, will be high. Okay, that's one of the factors which affects and determined by the capacitance of this cable. When you're revising about the transmission lines, you need to know all these factors which can determine their capacitance. Okay, check capacitance. Let me forward just Cx. Capacitive reactance will be Cx 2 pi Fc divided by 1. This is the formula for capacitance or capacitive reactance. This is capacitive reactance, which will be 1 divided by 2 pi Fc. C represents capacitance, and this is the formula you use for this capacitance. But the main cause, the main effect, the main parameter which affect these characteristics of transmission lines, which affect the electricity in the transmission line, is the resistance. Resistance affects most power losses in these transmission lines. We need to fight match this kind of resistance. Okay, this inductance, you can space them and avoid it. The same thing in capacitance also determines in the capacitance of these cables, and that is how we deal with these parameters. Though the fourth one we shall not much discuss about it, which is the conductance. The conductance, but the conductance is the conductance of the material, how the material is able to conduct electricity from one place to another. Okay, and if you know basics in transmission like this, I wouldn't have left this behind, because I want you, because if you master transmission the way you have seen generation, if also you master transmission, you'll be good to go to be doing good in distribution. That's where we're heading, distribution. Anytime soon we are starting the distribution. I know a lot of electricians, a lot of students like mastering distribution much, because distribution has a lot of work you're doing every day and now in distribution. But transmission is less, unless when you apply in transmission companies, but you need to have the knowledge behind it. If you don't apply for transmission companies, you need to have the knowledge. Okay, if you have this knowledge, I will thank you and say you are moving apart. You are becoming an engineer, technician, electrician. If you're doing electrical engineering, it's a very big way to have a greater future, to master the things which we are studying on our channel, the physics mindset. We are bringing small topics, but with conch knowledge and pure electrical information. What will I say? I will say thank you for watching the video. If you're new, turn on the notification, subscribe, and comment anywhere you want to learn anything which is difficult in your electrical phases, which part you're having some difficulties in electrical. I can come in and I help. Thank you for watching. See you in the next video. We are soon finishing the transmission topics. Okay, now we have studied about the transmission line perimeters, and these are resistance, inductance, and capacitance. Though even some others can learn about the conductance. Okay, see you in the next video about the transmission chapters. Soon we are finishing them and we go on distribution. Thank you for watching.